very convenient for a software engineer. It is very easier for a computer science engineer when you have so many cases like you can program it very easy any application. But whereas when the register number of register increases, it is a very big headache for hardware. Okay. So ARM32 has only 16 registers, so the hardware complexity of ARM32 is very much lesser than RISC-V. So if I can lead you through the complexity of each processor. So in an x86 processor, instruction units are flexible instructions varying from each instruction varying from x86 processor is E8. So whereas 50-bit instruction is this much, you can not even read that. And when it is assembled, it goes into hexadecimal of. But here comes the main advantage of PRISC-V. So all the instructions are 32. So whatever be the instruction, it is all 32 bit. Okay. So it is very easier to define the hardware. And if you can see the progress of x86 instructions, so in 1978 it was 80 instructions, and when it comes to 2014, it is 1330. So what could be the reason of increasing the number of instructions of a particular processor? What could be the reasons? In 2014 also the increase, right? Like the operations are not growing, but what could be the reasons that instructions are? Whether if anyone want to interact me and ask any doubts or queries, please always listen. Okay, so the reason is that uh, the need for parallel computing is. Okay, uh, so in the AI era, so we need to do various computations, various convolutional operations, various mathematical multiplications. So the need for parallel computing is increasing day by day. So this is the reason why the number of instructions is increasing because we need more. If we compare the cost of farm versus right, we know that still fabricating that is always proportional to the time, and it is square of 90. So proportional cost is a function of square of 90. And first by is much similar than so if we compare RISC-V rocket processor and ARM32 Cortex A5, which is very popular, like you have seen the STM32 boards at all. So it is very popular. So if we compare the two processors, and if I have taken this RISC-V rocket processor and ARM32 Cortex A5 processor, the TSMC 40 G plus dot, and with the same criteria of ARM32 will come to 0.53 millimeters. So, okay, so we have almost twice the area in our campus. So, obviously, the cost of fabrication will be increased 4 times. So, this is one of the problems why all the companies are going for RISC-V open source based architectures. But also another thing is that you all know that ARM is a proprietary and RISC-V is open source. So if it is a fabless company also, to buy the core of us, we will have to pay lakhs and crores. Whereas RISC-V is completely free. The basic instruction set architecture is completely free. We can take it and comparison. So we compare the cores of various processors and it is relating to RISC-V processor. So RISC-V 32 is normalized around one. Another version of RISC-V 32, so RISC-V 32G is 1.37. The thumb instruction set is a very reduced instruction set. Optimized instruction set architecture is around 0.99. Whereas the regular ARM32 architecture is 1.34 and Intel x86 is 1.26. Okay, so it is almost comparable, right? The spike code size and the ARM-based code size is always almost comparable. There is no issues. And so if I am taking various processes. So ARM32 for doing this insertions or program, it will take 90 instructions and it will lead to 76 bytes. Thumb has 18 bytes and 18 instructions and 46 bytes. And you can see RISC by the two idea. It will take around 90 instructions and it will also lead to 76. So here also it is compared. RISC by and ARM based processors and the mix is also we have compared. Okay. So you will not lose performance if you go back. So it is the underlying point. Okay, so now I will jump to the architecture. So very lightly I will touch on the architecture. So as I mentioned, my main aim is that you all have learned it out in C process. And the main addressing most is relevant to respond to architecture. UVH is the direct based in the reasons. And you know the immediate addressing mode, we have an immediate data and register direct addressing mode. The data is directly available on the register. And the register indirect mode, the data corresponds to the memory address and the memory address and the memory we have the actual data. And base offset addressing is very relevant to us, right? So we have a data in the particular register R1. And we also have an offset value. So if the offset is say 9, for 51%, 460 is the address. And these are the examples of load and store instructions. So load instruction, you can see the instruction format. Interface that's blue one and R1 and now so what I will do is I will take the value of R1 and with the offset value is 10, which corresponds to a memory address. And that memory, the value from the memory address is given to step. The reverse thing happens in store word. In store word, we have the register R and 10 is added. The offset value is added with the data in register R2. So here I have also another example. So I will go into it. Okay, so now I will directly go to micro architecture. So micro architecture, there are two. Is there any question? Data part, right? Okay, so this is the whole flow of the atomic architecture of our processor. So first in BC, we have a physics. Also, information will be focused on the digital circuits. And with the digital circuits, we develop the logic, and with the logic, we have the micro. Then we have the top level, like architecture, operating system, application software. Okay. So in the respect, we are following two approaches. We have a single cycle processor and a multi-cycle processor. Actually, we have three approaches. We have a single cycle processor, multi-cycle processor, and pipeline processor. So in single cycle processor, each instruction executes in a single clock cycle, and all the operations of a particular instruction is completed within that cycle. And the longest instruction determines the cycle. Multiple cycle, what we do is we reuse the different steps, and it is done over multiple cycles. And it has faster flow due to short stages. And the pipeline processor, which is most effective, each instruction is split into pipeline stages, and multiple instructions are processed simultaneously. So pipeline stage, pipeline design is the best room, and it is ideal for high performance CPUs. So if we go into processor performance, so the processor performance, one of the parameters is execution time. So execution time is given by number of instructions in the cycle per instruction, is CPI into seconds per second. Okay, so number of instructions is a program dependent. Is tiny instructions to complete that operation. So it is program dependent. CPI is architecture dependent. Is it single cycle, multi cycle, pipeline? Seconds per cycle is technology. And we have to satisfy these constraints, cost, power, and work. So if we see the RISC-V instruction subset, we have R-type instructions, which is mainly arithmetic and logical instructions. For example, we have subtract, etc. And we have I-type instruction, which is lower instruction. S-type instruction is low, and branch instruction, E-type instruction, B. So these we have a program counter, we have an instruction memory, a register file, and a data memory. So these are the basic architectural state elements with which we build the complete microarchitecture. Okay. So first we will take the example of a single cycle processor, and we will take the data path and memory. So I have an example program. So for this particular program, I am going to build the microarchitecture. Okay. So here you can see I have a load instruction, a store instruction, and on instruction B. So which corresponds to I change the state R time event. Okay. And I'm going to implement the instruction format. I have an X6, which is a register, and X9 another register, minus 4 is the cost. So I type instruction. This is the frame formatting. So I have an immediate data, equivalent with immediate data, which comes also with 31 to 20. And what is the need for immediate data? Because we have an offset. Okay, so to include the offset, we have an immediate data. Then I have the source register, RF, which is represented in mix. Then function and operand. So function and operand basically determines the type of operations. And then I have a destination, which is also fine. Okay, so instruction is in the instruction memory. Program counter loads the address. You all know the button of program counter. That's also the solving instruction with the If the address is 1000, my program will contain point 2. So address 1000. And in the particular instruction memory, from the instruction memory, he will fetch the load instruction and the machine code for the load instruction is f of C486. Okay, so that particular instruction is fetched. Second thing, system X, which is 6. Okay, X6 is my source system, which corresponds to 100. Sorry, X6, X9 is my source register, which corresponds to 1001. X9 is the register. So from the instruction memory, we'll go to the register number 9 and assume that in the register 9x9, I have the value 2000. So from the register file, from the corresponding register file, the data is what? This is 2000. Now, third step is extending the immediate. So, so -4 when converted to machine code is f of c. Okay. But it has only 3 bits, but the complete immediate data corresponds to 12 bits. Okay. So I have to extend this immediate value. So since it is a negative value and I have the sign bit in the front, so I will add all ones here towards the end. Okay. So this data corresponds to f of a. So I have extended the immediate data. Now the immediate data and the value in the register X diagram is given to an ALU. And you can see that the control line, the blue 000. So ALU control is a 3 bit control signal and it has 000. So when the control signal is 000, the ALU understands that you have to add the keywords toward operation in our spy process. And also we have one more step that which is to increment the program. So program number now should look at the next instruction to be executed. So this comes in positive value is taken and it is added for course it is in still my everything is generated by this word. So these two are added and the program total is completed. So this is a complete flow for a lower word instruction. Okay, so you can see that you can see the differences here. So the first difference is that there is a control signal coming to the side extender. Okay, so the immediate shows this particular control line is one. So with this control signal, the extender you understand that it is a store word instruction. Okay, and also here the immediate value is +8. So you don't need to add the sign. So the another difference is that so we have a read data. So first values I need data is here you can see where so the data is returned into the memory. The store word the data is into the data. So this is a difference with store word instruction. Next one is R-type instruction. Okay. So R-type instruction, we do various mathematical and logical operations. So the difference in R-type instruction is that so here you need to write the data into a particular register because you can see the instruction format like or X1, X5 exists. So we need to add the we need to all the data in X5 and X6 and we need to write it in the register X5. So the data, final data should be returned to a register. So it, and in addition, we have a mux here. So you can see that in R-type instructions, there will not be any immediate data. Okay. So to mask this immediate data, we need another mux, and the control signal for this particular mux will be zero. So with the zero, we can understand that there is no immediate value, and this just data and value go to the and here you can see the control signal is 0 1. For add operation, it was 0 0 0, whereas for all operations, it's 0 1. So ALU understands that you have to do the. So if in X5 say the data is 6, in X6 the data is 10, then it will do the all operation of 6 and 10. So you can work out on that and you can see that down into the data memory. So the data memory can be split. So we have another mux here, and the control signal result source for this particular mux will be 0. So with 0, this signal from the AE, the output from the AE will directly go and it will write to the register. Finally, we have the branch instruction. So branch instruction, will compare the two register. So, for example, here the instruction is EQ, which stands for branch is X4, X4 is so here the contents of register X4 and X4 will be compared because like we need to show this equal. So I have taken this particular example. So the two data particular is given by the data. Okay. So the changes to understand this branch operation, we have the immediate source here 1 0 because in the immediate here the immediate data corresponds to this label, particular label L7, and the ALU source is 0 and the ALU control line is 0 0 1. So if the two data in the corresponding two registers are equal, the zero register will be set. Okay, if the zero register is set, so zero, the zero register, in zero register it is by default the value of the zero register is zero. So if the two data are equal, you will set the zero register to one. So if when the zero register becomes one, you can add. So if the two data are equal, we will program counter immediate data. We will add these two together and it will go into the label and the program counter will now updated to. So to update the program counter, the another part comes the ECR corresponds to the EC source and it will be active. Okay, so this is the complete hardware by processor. So we have the data part here in the bold black line and we have the controls in the blue. This is the comment down. These are the control lines that I have said. So it's a high level view and it's a low level view. So in the low level view, this control. Example, the ALU architecture. So here I have taken only 5 operations, which will be the architecture of it. So I have an add operation, I have a subtract operation, so I have an adder. And to do the subtraction, I need to do the fuse component addition. So So to do the two's complement addition, I have a inverter and a mux combined with that. And I have an add operation, no operation, I have also shift left. And this is the decoder. So these all things are flexible. We can design it with our convenience. So when I come to uh, single cycle processor performance, it corresponds to the longest data. And the longest data path is executed by the old one. In the blue color, you can see data path for the old word. So it starts from PC, it goes to the instruction memory, it goes to a step file, it goes to ALU, it goes to a data memory, then it will turn to the register. Okay, so these are the models of critical path of a single cycle processor. So it will be reduced to this particular instruction. And if this is my complete data, and this is my single cycle data type, so I have programmed delay corresponding to memory delay time. Memory delay time is 200, which is the longest time. And register file read, so I have the register file read here 100. ALU 120 max, this will be very much less, it is 30. And register file set is also very easy. So when you so can you do an add operation here? String, uh, so TBC to C will be 40 plus T memory 200. So 2 equal to 440 R 60 months is 30 690 is step file is so 7. So the total delay here is 750 picosecond. And if we apply it in this particular instruction, so 7, say, the program we are doing is 100 billion instructions. The program we are going to implement has 100 billion instructions. So 100 billion instructions. So the total number of instructions will be 10 raised to 11, which 10 raised to 9 into 10 raised to 11. So we will have 10 raised to 11. CPI is counts per instruction. So since we have a single cycle processor, it is always 1. Okay. And EC is 750. Okay, so 750 microseconds. So 750 to 10 raised to minus 12. 1 into 10. Okay. So 75 seconds is the total execution time for a single cycle processor. So remember this value is 75 seconds. Now we have to compare it with the multi-cycle. Okay, so now when we come to the multi-cycle thing, so what we do is that, so in the single cycle, we have a different instruction memory and different data. So what I will do is I will combine instruction and data memory. So the hardware is reused. So this is the main difference in multi-cycle. Okay. And since the multi-cycle, the instruction is split into different cycles. So every instruction should have a buffer to store the particular data. So in the sense of state fetch instruction, we have a third one, computing the memory address. So output of ADAT as a buffer. And read data. Again, we have a buffer here. Writing back, we use a mux. we have implemented the program. So the only basic difference is that we are now combining the instruction and data memory and also we are using buffers. Okay. So if we go to the multi-cycle processor components, I take an example for particular instruction and say an instruction, the branching instructions take 3 cycles to complete. And if I take a benchmark just like 2000 CPU, and if I compute the CPI, with the benchmark of Spectrum Universal, take 25 percentage of for load instruction, 10 percentage for store instruction, 13 for branch, 52 for part-time. So the average CP will be the weighted average of. So when comparing, I will get this CPI as it was one when compared in second for synthesis. Okay. So again, for estimating the multi-cycle cost of performance, I will take the Pickel Parker, which is also used for integration. And this is the model for have the data here and I have the model here. So I have computed it. So CP is 4.12. So we are taking same example as single cycle processor. So I have taken
ಇದಲ್ಲ
20
ಇದಲ್ಲ
million
microphone ಅಲ್ಲ.
and the clock cycle
ಬೇಡ ಇದು.
time will now
Hmm.
is 375 microseconds by adding with the
Please
model.
add.
And the execution time, so if you can calculate here, is the same 100 billion instructions, so 10 base 11. The 4 point is the same 100 billion instructions, so 10 base 11. The 4.1 into 375. So when calculating this, it will be around 150 seconds. Okay. So in multi-cycle processor, 150 seconds, and there are single cycle processor, recording 75 seconds. Okay. So they need to improve the user performance. This is what we say. So the only solution is pipeline. So I will not go into the pipeline mistake. So all the architectures are same. Only thing is we have to split the differences. So you can go and work from that also. So now we will see the third part of the talk, third and final part of the talk, which is the REST-FI that REST-FI deployment in AI. Okay. So the question is, can we deploy a REST-FI in AI application? The answer is partially yes. We can use a go for AI apps like this. In the current research adventures, the main thing they're focusing is the metrics one, because you know that for any machine learning application, the thing is AX plus B. So you have to multiply the weights and the inputs, and you have to add that bias value. So the main thing is the matrix value. And we have the hardware notebook. So why we go for very specific hardware, say ARM processors, the Raspberry Pis, the Oreos, why we go for specific things? Because it has specific architecture which is custom made for the RISC-V. We can customize it. We can customize the instruction set architecture, and if we customize the instruction set architecture, which is suitable for a machine learning application or a deep learning application, we can very well deploy RISC-V for these particular AI applications. Okay. So how to escape the hardware notebook? So I have two use cases, which is very prominent in the current research thing. So first thing is real-time image processing that involves a mix of ML and conventional ESPs. So how will the latency of these two things be? So the latency between these two units is so short time, and this ML will take much larger time. Okay, so this is the reason why the AI deployments becomes harder in hardware. An example too, researchers develop a new type of activation function, but there is no hardware available to. So what is the problem with the activation function? So if you look at the sigmoid activation function, it has an exponential value. And yeah, and you know that the exponential values we cannot implement in hardware. Okay. So what will be the possible solutions in example one and example two, and we have to escape the hardware code. So the possible solution is reduce the latency between these two units, and it can be done in say matrix multiplication, which is done stochastically, and you there is the there's like sparse multiplication, etc. So in sparse multiplication, we will omit the non-relevant particular data. Okay, so sparse multiplication is a solution. So in the REST-V architecture, we can very well extend to an instruction set which can do sparse multiplication. And in the second thing, activation functions cannot be implemented in hardware because it has exponential term logarithmic terms, etc. So you can very well approximate the. There are various mathematical ways to do it, and you can very well approximate this, and you can implement it hard. Okay, so the value proposition of Holistify stands in customizability, scalability, and open, which I have already discussed. And yeah, so I think I will stop this slide. And these are the different methods available in current literature with which we can deploy a RISC-V in different AI aspects. So the first method, okay, so first method, you can see that you have individual CPUs and also you have RISC-V. Exist parallelly in a particular system. And in the second deployment, you can see that there are various CPUs and you have a RISC-V written within. And RISC-V acts as an interface between the various CPUs. So in the various CPUs, various operations can be run. And RISC-V acts as a interface. And in the third one, RISC-V is the major player in this particular system. And to complement the RISC-V processor, we have different CPUs. And whereas see that realistically, the first two architectures are most popular now. So first two architectures can be easily deployed in AI application, whereas third and fourth is still explored. Okay, so I will not go further. So I will stop it slide, and we have 5 minutes more. So if there is any discussions we can. So I think we have
On behalf of College of Engineering Chennai, I extend my sincere thanks to Dr. Arun Toyi for the insightful and inspiring session. Your valuable perspective and clarity have greatly enriched this conference. Thank you for sharing your time, expertise, and experience with us. It was truly an honor to have you with us today. Thank you, sir.
to engineering education. A joy to kindly take the chair and guide the proceedings of this session. And moving to the next chair, Professor Mahesh Bias. He is a PhD research scholar in machine learning with a strong academic background in electronics and communication engineering. His current research focuses on deep learning-based detection of diabetic retinopathy using advanced image processing and computer vision technologies. He has published several research papers on the topics including glaucoma technology, detection, face spoof recognition, and text recognition using Poisson filtering. Beyond research, Professor Mahesh Bias is passionate about monitoring and mentoring students developing innovative teaching methods and applying AI solutions to real-world healthcare challenges. Once again, I inviting Dr.
We are moving to the first presenter of the session, Ms. Akshaya Rajesh from CEC.
Hello, am I audible?
Yes, you are audible. Please share your screen.
Okay.
Presenters, please note that the time for presentation is 10 minutes.
Is it visible?
Yes, it's visible.
Okay, thank you. So, good morning, everyone. Respected panels.
Akshaya, your screen is visible, but the slides are not visible.
Is it visible now? Let me check once.
We have tried different notes. That same screen is showing there.
Okay.
It's not an issue from here, actually. Please log out and log in again.
Okay, I will.
Akshaya. Please open your presentation.
Akshaya,
Hello.
you send me your slides to this mobile number.
Okay.
WhatsApp. And no issue. Slides are here. എനിക്ക് അതായിരിക്കും ഇത് ഇതും കൂടി ഞെക്കിയാലും ഇങ്ങോട്ടാണ് അതാണ്
Is it visible now? Hello?
You can start.
The slides are visible.
Visible now?
Yes, it's visible.
Okay. So I'm realizing the details and the future scope. Healthcare systems today face challenges such as long waiting times, manual processes, and limited access to medical professions. In many cases, patients need to visit hospitals physically, even for minor health issues, which increases delays and workload. Digital healthcare platforms help overcome these challenges by enabling online doctor consultation and remote access to healthcare services. When focusing many of them lack proper prescription handling mechanisms. Manual prescription reports and verification can lead to errors, misuse, and incorrect medicine delivery. To address these issues, this work focuses on secure digital prescription generation and integrated healthcare platform. So let's get to the objectives of this work. And the main objectives are to enable online doctor consultation and the appointment scheduling, and to implement a secure digital prescription management, and to automate medicine ordering using a prescription validation, and to reduce manual errors and improve healthcare efficiency. And these are some of the related works. Existing telemedicine systems, which mainly focus on remote consultation but do not include prescription validation. And when it comes to the proposed framework, the proposed system is a web-based healthcare platform which integrates online consultation, digital prescription generation, validation, and medicine delivery. And this framework ensures that medicines are provided only after prescription verification, which improve safety and reliability. This is the architecture. This system architecture defines how different components interact with each other. It supports secure communication between patients, doctors, ability, and easy future enhancements. Let's get into the system modules. This contains three main modules, which are user module, doctor module, and admin module. And this user module, which handles the patient registration, login, and appointment booking. And the next module, doctor module, which manages the consultation and digital prescription generation. And the admin module, which controls system monitoring, user management, and data validation. And this role-based access control, which ensures a secure usage. And about the consultation and prescription flow, patients book appointments through the online interface, and the doctors conduct consultations remotely, and they generate digital prescriptions based on the diagnosis. And these and about the medicine ordering and delivery. Once the prescription is validated, medicine ordering is enabled. Requests are sent only to authorized pharmacies. And the system tracks delivery status and updates the patient, ensuring timely and accurate medicine delivery. And this is the technology stack, the implementation. And the Okay, when comes to the prescription processing, prescriptions are generated digitally after the consultation. Key medical details are structured and stored in the database. Rule-based validation ensures that prescriptions are authentic and complete before medicine handling. About the system integration and workflow, all modules are integrated into a unified healthcare platform, and this these modules, which is users, doctors, and pharmacies. And manual intervention is minimized, which improving the efficiency and the reliability of the system. And the future scope. Future enhancements, which include AI-based decision support for doctors, a real-time video consultation, and integration of wearable health devices and advanced security mechanisms. And by concluding this proposed system provides an integrated solution for online healthcare management. And this important thing, which is the digital prescription handling, which improves the accuracy and reduces the errors. Overall, the system enhances the accessibility, efficiency, and reliability in healthcare service delivery. Thank you. This is all about the work, and thank you for your time and attention.
Hello. Am I audible?
Hello. Yes, you're audible.
Okay, congratulations, Akshaya, for presenting a paper in this conference.
Thank you.
Okay, so you said it's improving medical accuracy. How this medical, what do you this medical accuracy, how it is improved?
Actually, this current systems focuses only on the consultation. Actually, they do not provide any automated prescription validation or integrated medicine delivery. But this system addresses this gap by combining this both, and which improves this medical thing.
So how that security and validation is done?
With validation, and which reduces
So how
this
is
medication
it
errors.
validated?
Prescription validation, which is implemented using a rule-based validation logic, which is used at the backend. A rule-based validation.
So how the scheduling is done?
Sorry?
How the scheduling, consultation scheduling is done?
Currently, actually, it's a scheduled consultation because they can book the time, which is the consulting time. Actually, the future enhancement is the real-time consultation. Currently, it's a scheduled consultation one.
Okay. So is there any provision to store the patient records?
Yeah, relation database is used here for a secured storage.
So when a patient approaches the next time, the doctor can consult the earlier records?
Yes, they can. Because data are securely stored in the database, which we are using this relational database management system.
So you are providing a user login and all?
Yes, we are.
Okay, thank you.
Thank you so much.
Okay, thank you. You can leave now.
Okay, thank you.
Now we are moving to the next presentation. Ms. Elizabeth K. Thomas.
So, hi, sir.
Hi, please share your slides. Yes, the slides are visible.
Okay. Good morning to all. Respected dignitaries, faculty members, and participants present here. I'm Elizabeth K. Thomas, a final year Electronics and Communication Engineering student from College of Engineering, Cherthala. Today, I'm here to present our conference paper titled The IoT-Based Mobile Robotic Arm for Object Handling and Hazardous Fume Detection. So as we go into this introduction part, we can say, as we know, in many industrial environments such as the chemical plants, gas storage facilities, and confined production units, the workers are still required to manually handle the objects in areas where hazardous gases may be present. So despite the advances in automation, human exposure to toxic environments remains a serious safety concern. Now, while the robotic arm assists, most of them are stationary and operate without environmental awareness. At the same time, gas in here there exists a disconnect between this environmental intelligence and robotic action. So this motivated us to design an integrated IoT-enabled mobile robotic platform, which is capable of both object handling, that is the pick and place, and the real-time hazardous gas detection. So moving on to this system overview, our proposed system consists of a mobile robotic base, that is a mobile vehicle, robotic vehicle that is integrated with a multi-degree of freedom of robotic arm. So at the core, we are using this Raspberry Pi 3 Model B+, which acts as the central processing unit, is managing this actuation, sensing, and communication. The system integrates the three primary modules, which are, first we can say about the robotic arm. There is robotic arm is for this object handling, that is for the pick and place things, and the gas detection we are the IoT applications. Okay, then to understand more about how these modules interact, we will explain now the system architecture. Okay, the process begins the system initialization phase. That is when the robotic vehicle and Raspberry Pi are powered on. Once the network is established, the system connects to this MQTT broker. As we know, what is MQTT? There is a message queuing telemetry transport. In here, we selected this MQTT because due to its lightweight published subscribe architecture, which is well suited for the IoT-based real-time control system, which acts as the smart messenger service between this app and mobile robotic platform. So, and our Android application, which consists of two things, that is provide two independent control interfaces. First one, you can say that the slider-based servo positioning for the robotic arm control. Backward, left, and right button-based directional commands for the navigation. And these commands are published to the specific MQTT topics, and the Raspberry Pi subscribe to those topics to receive the real-time instructions. So based on these received real-time instructions, this Raspberry Pi processes commands, that is either it can control the servo motors of the robotic arm or the control the vehicles of the motors. That is control the DC motors of the vehicle, robotic vehicle. And like that, this robotic arm and vehicle is moved. Simultaneously, in addition, we added this Raspberry Pi camera module to it because we can see the onboard camera streams the live video back to the application, allowing the user to monitor the operations so that user can monitor and live feed. And after that, we can stop and disconnect this MQTT. Again, this is how our robotic arm looks like. And in here, we can see that we consist of the base, the shoulder, elbow, wrist, and gripper joints. Each joint is actuated using an individual servo motor to enable the precise and angular position. So all these servo motors, that is the base, the elbow, the shoulder, the wrist, and the gripper, these servo motors are controlled using this PCA 9685 16-channel PWM driver. This is integrated with the Raspberry Pi through the I2C communication. So the IoT application provider the slider-based input for each joint, allowing the user to control the angular positions in real time. That is all about this robotic arm. And as moving to this mobile platform and navigation, that is our robotic vehicle. Our robotic arm is mounted over this robotic vehicle in real world environments. We mounted it on a robotic vehicle that allows the entire system to move to different locations instead of being fixed in one place. So the user sends the navigation commands such as the forward, backward, left or right through this IoT mobile application. And these commands are transmitted via Wi-Fi, processed by the Raspberry Pi and converted to the control signals in real time. And in addition to that, we also added this gas sensor, that is the gas detection and monitoring. To enhance the safety, system continuously monitors the environmental gas concentration using this MQ135 gas sensor. The analog output from sensor is converted to the digital in the form of ADC module. This is how the user interface looks like. And we can see these gas levels, like it says status, safe, warning, and danger. So based on is considered as the safe. When the value is rises around 1548, we can say that the atmosphere is around warning stage. And when it exceeds this 1665 value, we can say it is a danger. So these threshold values were determined through the baseline observation and comparative analysis. So first we recorded the sensor output under normal air conditions to establish the stable reference level. And that reading was around 1102 to 1150. So thus we expected that this sensor is to the higher concentration. And by evaluating under this several assessment, we found this threshold values as well. So for the danger state, dual alert mechanism is triggered, like local buzzer warning, and also the notification sends to the IoT application. So moving to this results and this architecture. The real-time hazardous gas detection with threshold-based alert system, the live video streaming with minimal latency, the accurate execution of remote control commands via Wi-Fi, the smooth coordination between this robotic arm and robotic vehicle, the reliable performance under the controlled indoor testing conditions. So this is how our final outlook of our model looks like. We can see this is the four-wheel chases of robotic vehicle, and this is the robotic arm which is mounted over this robotic vehicle. And we can see this is our core part, that's a Raspberry Pi. And we have in here also we have gas sensor of MQ135, and also the Raspberry Pi camera module is situated in this robotic cam for the live monitoring. As we're coming to this conclusion, we have designed and developed an IoT-enabled robotic platform integrating the gas detection, video streaming, and remote control. Preliminary testing straight in the control environments. The further optimization and extended field testing are currently in progress to enhance the reliability and scalability. So this is all about, and thank you.
Hello.
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 Hello. Okay.
Congratulations, etc.
Okay.
So is there any power constraint for the robot?
Hello.
Hello. Hello.
Okay. Hello. Okay. Can you increase some more voice?
Hello.
Hello, ma'am. Okay.
It's clear.
Yeah.
Congratulations, first of all.
Okay.
So is there any power constraint for your robot?
Yeah. Okay, so our system operates on a rechargeable battery supply. Since it integrates this motors, Raspberry Pi, camera module, and Wi-Fi communication, The DC motors and servo motors also draw the peak current during the actuation, while Raspberry Pi consumes the continuous power for the processing and network. So therefore, the operating time depends on the power capacity and duty cycles.
Hello.
Hello.
So what are the movements of your
Robotic arm. Hello. Robotic arm, right? So as you can see, this is a robotic arm, and we used 5 servo motors. That is for the base, for this elbow, this shoulder, wrist, and grip. So it can move in 180 degree and from 0 to 180 degree. So we can actuate this angular modulation. Hello, is okay?
Okay.
Okay.
Next presentation.
We are moving to the next presenter, Ms. Sri Lakshmi B. Ms. Sri Lakshmi.
Hello, sir. Can you hear me?
Sri Lakshmi, can you hear me?
Yes, sir.
Please share your slides.
Sir,
Yes, it's visible now. Yes, it's visible.
Can I start?
Yes, you can start.
Good morning, panel. I am Sri Lakshmi B. I am a final year MCA student, College of Engineering, Cherthala. Today I am presenting my work titled Malware Detection using Machine Learning. This project focuses on static analysis with online threat intelligence verification. So this is overview of my PPT. So we move to the introduction. Malware has become one of the most serious cybersecurity threats today. Traditional antivirus systems mainly use signature-based detection. This means they compare a file with a database of non-malware signature. This problem is that this method cannot detect zero-day attacks or newly modified malware.
Sri Lakshmi.
Modern malware is
Hello. Sorry for the interruption. Can you turn off the fan? It's a little bit noise.
yes, sir.
Start. Continue the presentation.
Okay, sir. Malware has become one of the most serious cybersecurity threats today. Traditional antivirus systems mainly use signature-based detection. This means they compare files with database of known. Modern malwares also hide its behavior using encryption and packing techniques. So instead of searching for exact signature, the system analyzes internal file patterns using machine learning to detect malicious behavior. The objective of this works are first to build an automated malware detection system, second to analyze the executable files safely without executing them in the system, third to improve detection reliability by combining machine learning classification
Sri Lakshmi. Sri Lakshmi, hello.
Sir, can you hear me?
Yes, I can. Sure, you can continue the presentation.
In the literature survey, existing work mainly focus on a static machine learning models such as random forest, SVM, and decision tree for malware detection. However, most of them only on static analysis and lack of hybrid verification or external threat intelligence integration. This motivated the development of my proposed hybrid approach. The proposed system works in multiple stages. When file is uploaded, static feature extraction is performed. Important features as a file metadata roles and entropy values are extracted. These features are converted into a feature vector, and inassembling classifier combines support vector machine and random forest and predicts whether the file is safe or malicious. If you reputation, finally both results are combined to generate the final report. The system architecture. The system user either a file upload or a URL. The file goes through feature extraction, entropy analysis, machine learning classification. For URLs, the system performs online reputation verification using VirusTotal. The final decision module combines the analysis result and generate a security report. This modular architecture ensures accuracy and reliability. Then the entropy analysis. One important feature used in the system is Shannon entropy. Entropy measures the randomness in file data. Encrypted or backed malware used to show high entropy. The formula is used. P of xi log the base 2 of P of xi. High entropy indicate the possible malwares. This helps in detection malware that hide its structure. In machine learning models, the system uses an inassembling model combines support vector machine and random forest. Support vector machine helps in finding the optimal decision boundary for classification. Random forest provide probability based confidence. The final decision is determined using adaptive thresholding based on file type. This reduces false positive significantly. Then implementations. The system was developed as a web-based application using Python and Django. Static analysis performed without executing the file. Pre-trained machine learning models are loaded for classification. For URLs, the system queries the VirusTotal API and retrieves reputation data. A security reporter. So the result, the system was tested using being a malicious executable samplers, though the in-assembly model achieved 96.2% accuracy, 95.8% precision, 1.2% false positive rate. Compared to traditional system, the proposed model performed better in detecting unknown malwares. Detect time is less than 1 second, making it suitable for practical usage. In the comparison table, the traditional and my system. This table compares traditional signature-based detection with my proposed hybrid machine learning system, showing improvement in unknown malware detection, reduced false positive, faster processing, and URL verification. The experimental evaluation show that the proposed system are faster detection time and support unknown malware detection compared to traditional system. The main advantage are the detect both known and unknown malware, does not execute suspicious files, reduce false positive, integrated online threat intelligence, provide fast and detailed reports. Then the future scope. In future, the system can be improved by adding dynamic sandbox analysis using deep learning models such as CNN or RNN, supporting mobile and multi-platform analysis, integrated continuous threat updates. To conclude, this work presents a hybrid malware detection framework that combines static machine learning analysis with online threat intelligence verification. the inassembled SVM and random forest model takes fast automated malware detection. Overall, this framework enhances cybersecurity detection against evolving threats. This is the reference. Thank you.
Sri Lakshmi, can you turn on your camera?
Sir,
Can you turn on your camera?
okay, sir.
Can you hear me?
Yes, sir.
Okay, congratulations, Sri Lakshmi, for presenting a paper.
Thank you, ma'am.
Okay, have you compared your result with any other models presented in your literature survey?
Ma'am, it's not audible. I can hear.
Have you compared your result with any other models presented in the literature survey?
Sorry, ma'am. It's not audible.
Hello?
Yes, ma'am.
So have you compared your result? What's the results now?
How I come?
Presented in your
I can hear. Hello, ma'am. Can you hear me?
okay, it's better to give a graphical analysis. Give some graphs at the end.
It's not audible to me. I can hear.
Are you turning your screen?
Hello?
Yes, ma'am. Yes, ma'am.
Okay, it's better to give some graphical representation of your results. Okay.
Yes. Yes.
Okay, thank you. So you can leave.
Thank you, ma'am.
Mrs. Sri Rashmi PM. Ms. Sri Rashmi,
Yes, sir.
please share your slides. You can start the presentation.
Okay. Good morning, respected chairpersons and fellow researchers. I am Sri Lakshmi PM, and today I am presenting my mini project titled Blockchain-Based EOD System. This work focused mainly on improving election transparency, security, and trust using blockchain technology. And these are the contents I'm going to cover. So the introduction. Voting is the backbone of democracy. However, the traditional voting systems suffer from tampering risk, centralized control, fraud possibility, lack of transparency. To address these challenges, we propose a decentralized blockchain-based e-voting system that ensures immutability, transparency, security, and trust. The objectives of this system is to develop a secure online voting platform, prevent privacy. And the scope of the system is enable secure remote voting, prevent third-party interference, and provide a scalable base for institutional level election. And this is the architecture of our system. And firstly, the voter casting the vote, then the system validating the input, third, the smart contract checking the eligibility, then the blockchain records the vote, and the results are automatically generated. This is how the workflow of the system. And here comes the modules, and the system consists of 6 modules. Firstly, the voter module, system module, smart contract module, blockchain network module, result system module, result publishing module. Firstly, the voter module, only the voter handling the registration and login and vote casting. The system module third, the smart contract module. It is checking the voter has already voted and it records the votes and updating the vote automatically. Fourth is the blockchain network modules, where the storing the vote permanently using decentralized ledger. And the fifth and sixth is the result, which where the votes were retrieved and published verified results. And here comes the implementation part. And the front end is developed using React, connected using web3.js, integrated with the MetaMask wallet. And the smart contract were written in Solidity, deployed on Ethereum, tested using Ganache. And I will explain you the voting process. When the user select the candidate, the transaction will be sent. That's how the voting process will done. And the performance evaluation, when comparing to traditional voting system and the blockchain voting system, security will be ensuring immutability and tamper-proof records. Transparency, when it comes to comparing the traditional voting system, blockchain provides transparent and verifiable transaction. Time efficiency, manual voting takes long time as compared to e-voting. E-voting enables instant and automated vote counting. Cost efficiency, traditional election requires physical infrastructure and manpower. E-voting reduces the operation and logical cost. Then the accessibility, traditional voting requires physical processes, but the e-voting allows remote participation through secure digital access. And the conclusion of this project is the system prevents voting, ensure this is the reference. And thank you for your attention.
Sri Lakshmi.
Yes, madam.
So how the, first of all, congratulations, Sri Lakshmi, for presenting a paper in this conference.
Thank you, madam. Thank you.
Okay, how the scalability is achieved in this voting system?
Can you repeat the question, madam?
How the scalability is achieved in this voting system?
Okay. Scalability is achieved by optimizing blockchain usage, separate on chain and off chain, and using currently it is used for small to medium scalable election, because we cannot use it for national level deployment because we need extra layer to scaling, and private blockchain and higher throughput blockchain infrastructure would be required.
You need something, some extra layer, software layer for scalability.
What, madam?
You need additional enhancement for scalability.
Question is not clear, madam.
So how the MetaMask is generated?
Okay, once the voter is select the candidate, generate the private public key pair using cryptographic algorithm. That's how.
Okay, thank you.
Oh, thank you, madam.
We are moving on to the next presenter, Ms. Fatima Kansa KR.
Hello.
Yes, Fatima. Please share your slides.
Okay. Is it visible?
No. Please share your screen.
Is it visible now?
Yeah, it's visible now. You can
Okay,
start.
let me start my first. Good morning, all. I'm Fatima Kansa Kea, presenting our paper titled IoT-enabled automated pothole patching robot for next generation roads, authored by Abhinavi, Nishida Sachi, Krishnapriya NU, and myself, students of BTech Electronics and Communication Engineering, and guided by Sajish M, Assistant Professor, Electronics and Communication Department, College of Engineering, Chatala. This work is mainly focused on automating the pothole detection and patching using embedded system and IoT for smarter roads. Discuss now and introduction. As we all know that nowadays potholes are major causes of road accidents, vehicle damages, traffic congestion, especially in urban and also in semi-urban regions. So the traditional pothole repair method rely on manual inspection and it can delay the maintenance, and which are a little bit of time consuming and costly, which is also unsafe for workers. To address this issue, we are proposing a smart robotic system that can automatically detect potholes and estimate their depth and then the patching process. And it is IoT enabled robotic system. Monitor. And the objectives of our project is that to design and develop a smart pothole patching robot which analyzes the pothole automatically, measure the depth using TOF based LiDAR sensor, and fill the pothole, which reduces human efforts and improve the safety. And the IoT is will give the real-time monitoring, and our project will give smart road infrastructure development. And now the problem statement. We all know that the frequent road damages and are frequent increases the accident risk and vehicle damages. So a manual inspection is inefficient, and the manual inspection will delay the repair time and the worsen the road conditions. So our system will automatically detect the pothole using a sensor, which is LiDAR, and give real-time monitoring and data transmission through IoT, and it automated the filling after detecting the depth and pothole. And we use ESP32 as microcontroller, and which to improve the road maintenance and safety. So these are the ones we used servo and relay module, ultrasonic sensor, DC motor, motor driver and TOF LiDAR. So this is the architecture of our project. We are using ESP32 as the microcontroller, and we are using IR sensors for the navigation and the surface detection, servo motor for the movement of the vehicle or the robot, and we use ultrasonic sensors which provide an additional feature for the obstacle detection, and then the main one, LiDAR. The LiDAR will provide the detection of the pothole. And we use, these are the power supply and power maintenance, buck converter used for the stable power transfer and working principle. So now I'm going to explain the working of our robot. The robot moves on a rod's surface continuously, and the sensor, which is LiDAR, TOF LiDAR, which will detect the surface irregularity and the pothole, which will be working in a 180-degree rotation. With the uses of a TOF module, and robot stops and performs the automatic filling of pothole or surface irregularities, and the robot then stops and perform the automatic filling of pothole. Once the automatic filling is completed, the system sends a status and update through IoT. So we can use that for the monitoring and implementation. Here we are using a threshold-based method for the pothole detection. When the detected depth exceeds a predefined limit, we have set a predefined limit as a pothole. The LiDAR sensor ensures the depth measurement and filling mechanism, and it dispenses the material in a controlled manner. All operational data is transmitted to the monitoring interfaces through IoT. Now we are going to the results. The prototype was tested under controlled conditions. Potholes were detected accurately during the movement. The LiDAR sensor provided reliable and consistent depth reading. The automatic filling mechanism is operated effectively through continuous test and evaluations, and the real-time data transmission is achieved through IoT. And the advantages of the project is that it improves the road safety and reduces traffic disruption during maintenance. It minimizes human risk in hazardous conditions, and which is provide a better protection to human life or the the person who's working in this road condition. And it can be used for the continuous road monitoring and assessment, and it promoted automated and smart infrastructure systems. So the application, we can use it in urban and semi-urban road maintenance, for highway safety, and also gives a protection to the people working in that region, and remote monitoring and disaster recovery. So the conclusion is that the IoT-enabled a pothole patching robot was successfully developed, and the system integrated real-time detection with TOF-based LiDAR estimation. The automated filling enables the accurate patching with minimal human interferences. And that's all. These are the references. And thank you. Is there any doubt?
Ms. Fatima and team for presenting a paper in this conference. Can you switch on camera?
Okay.
So you have different computer vision techniques for can you compare yours IoT based system with which one is which will be better?
So are you asking to compare my compare our project to another one?
Yes, with computer detection.
Yeah, this one. Some of the paper or some of the project that have used micro controllers like Raspberry Pi and the vision controlled basis, but they are based on vision control, and it can be complex sometimes. So we are using TOF sensor only, which give a millimeter range of depth measurement. And also there is another way that the projects have done, which is using ultrasonic sensors. But this using the ultrasonic sensor is not precise, because it only works in a measurements. So using a TOF sensors is much more better than the other ones. And comparing to the vision controlled one, this is less complex comparing to them.
Okay, thank you.
Okay, thank you, ma'am. Thank you, everyone.
We are moving to the next presentation. Mr. Akbar VA.
Yes, sir.
Akbar, please share your slides.
Okay, is this visible?
Yes, the slides are visible.
Tech in Computer Science in College of Engineering, Cherthala. Today, I am presenting our project titled Tech Pharma, an intuitive digital healthcare platform with real-time medicine locator, telemedicine, and AI-powered medical assistance. This project focuses mainly on solving real-world healthcare problems like difficulty in finding medicine, delayed doctor consultation. Through Tech Pharma, we aim to bring pharmacy search, telemedicine, AI assistance, and reminders into one unified platform. First of all, presentation. This was the outline: introduction, literature survey, existing system and disadvantages, proposed system, advantage and limitation, system architecture, implementation and tool, result, comparative analysis, This was the introduction. In this presentation, I will traditional healthcare system will still depend heavily on physical visit to pharmacies and hospitals. Also, many patients spend around 15 to 30 minutes just checking medicine availability in different shops. Also, studies how that nearly 50% of patients do not take medicines properly, especially elderly people. Currently, no single system integrates pharmacy search, telemedicine, AI guidance, and reminders together. So we developed Tech Pharma, a unified digital healthcare platform that connects everything in one place. literature survey. In our literature survey, we studied around 10 research papers and existing system, focused only in pharmacy. Also, others created GPS-based pharmacy locators like MedFinder and FarmFinder. Sure. Although they had some limitations also, no real-time stock updates, platform dependency, privacy risk, high computational cost, limited rural accessibility. This was the existing system. Here we analyze existing system applications like MedFinder, FarmFinder, PharmaFlow, and others. Each system solves one specific problem, either location tracking, reminders, or AI recommendation. Disadvantages and existing system. In disadvantage, their major disadvantages are no unified system, inaccurate real-time stock updates, like limited platform compatibility, also high setup cost, and app switching between different services. In proposed system, Tech Pharma solves all these issues by integrating multiple healthcare services into one platform. It includes medicine locator using GPS and Haversine formula to detect the nearby location of pharmacies, and secure telemedicine using Jitsi API. Application, SMS and email, online ordering with secure payment, and strong security with bcrypt hashing and role-based access control. These are the advantages and limitations of proposed system. Some key advantages are 87.3 stock verification accuracy, 1.8 search response time, 94.5%, successful video consultation, 32% improvement in medication adherence. However, there are some limitations also. GPS accuracy may vary, requires pharmacy API integration. AI depends on third-party uptime. Also, some high initial setup cost. This was the system architecture. Our system has 3 and TypeScript. Also, backend uses Golang, and we uses PostgreSQL as database. Also, external APIs include Jitsi for video consultation and OpenRouter for AI chatbot. Implementation. Earlier I said frontend uses React and Tailwind for frontend, Golang for backend, PostgreSQL for database, bcrypt for password security, cloud storage for prescription uploads. From testing with 200 participants, we know that 87.3% are stock accuracy, 1.89. And this result show that system performs efficiently under real world conditions. Healthcare outcomes. Beyond technical performance, we observed real healthcare improvements, 41% reduction in missed appointments, 27% reduction in emergency cases, 35 to 40% higher user retention. This shows practical impact, not just technical success. When compared to traditional methods, medicine search time reduced from 50 to 30 minutes to 1.8 seconds. App switching reduced by 95%. AI operational cost reduced by 40%. So TechPharma is more efficient, cost-effective, and user-friendly. User feedback. We tested different scenarios like medicine search, video consultation, AI queries, prescription uploads, and payment processing. All scenarios performed successfully, showing system stability and reliability. In future scope, we plan to integrate electronic health records, use blockchain for tamper-proof prescription, connect wearable devices, add mental health modules, expand rural connectivity using edge network. This will make TechPharma more scalable and intelligent. This was the conclusion. To conclude, TechPharma successfully integrates pharmacy search, AI assistance, and reminders into one unified healthcare platform. It improves to percentage. Additionally, the system can contribute significantly to the future of digital healthcare. This was the reference, and thank you.
Hello.
Yes, ma'am.
Okay. Can you switch on your camera?
Okay. Is that clear?
Yes, sir. So how you have
Hello?
can you hear me?
No.
How the testing is done? Hello.
No, miss. Voice not clear.
How the testing is done?
Yes, miss. Testing.
Yes.
We done testing around 200 participants, including patients, patients also, and some friends. Testing was done in multiple phases: functionality, security, and performance. Medicine search function available. Video consultation, scheduling, and connection. And there are also AI chatbot response accuracy, reminder notification in mobile phone, prescription upload and verification. We use real-time prescription and payment processing.
How the success rate is calculated?
Hello?
Okay, thank you.
Okay.
We are moving to the next presentation. Ms. Krishnapriya R. Ms. Krishnapriya,
Yes, sir.
please share your slides.
Is it visible?
Yeah, it's visible. You can start the presentation.
A warm and pleasant good afternoon to one and all present here. My name is Krishnapriya R, and on behalf of my co-authors, Abhijita Krishna, Ashwin Suresh, Gopika S. Nair, and Mr. Gokul Vishwanath, today I'm here to present our paper titled BioLib, a next-gen library system with biometric authentication and intelligent suggestions. Now, what we have here is a quick overview on what we are going to discuss today. Since our system, that is the BioLab system, is still a working comparatives and identify the research gaps and also done a system study. So let's start without any further ado. So we all know how the traditional library system works, right? The student needs to carry a physical library card with them every time, and these cards may get lost, stolen, or can be misused. And also, even after reaching the library and after long hours of search, they may not find the book that they are searching for. And in case of librarians also, the whole library operations like tracking and everything is highly manual. So all this results in human error, and also it's time consuming and it lacks security. So what we aim, or what our objective is, to reduce the error, accelerate transactions, and strengthen the identity assurance. That is to enhance the overall library experience. Comparative analysis, that is, we have evaluated the existing methodologies and identified how our system is different from others. So based on our research, what we can understand is that these three technologies, that is RFID, facial recognition, and biometrics, are the most common technologies used in the existing systems. And talking about RFID systems, that is radio frequency identity, even though it provides a robust anti-theft tracking, but this hardware cost is really high, which makes it less scalable. And in case of facial recognition, it provides high accuracy, but under controlled conditions only. That it requires a lot of conditions like proper lighting, proper alignment, and everything. So it is also not that efficient. Then comes our method, that is using biometrics, that is using fingerprints, and combines all the necessary technologies. That is, we can take the first paper, it only combines biometric authentication and web-based portals. And in case of second, it combines biometric authentication and AI. But in case of what we are proposing, that is a BioLab system, it combines all necessary four technologies, that is biometric authentication, AI, mobile accessibility, and web-based portals. Now we have identified some of the research gaps, that is, as I have mentioned before, the manual and RFID systems, it always remains susceptible to card loss and identity impersonation. And we can identify no framework unify all the necessary technologies, but our framework unify biometric authentication and mobile accessibility. Now we have done system study and the existing workflow. Talking about the existing system, it is highly dependent on physical cards, and also there's proxy borrowing, that is, there's can be impersonation and everything. And this whole transactions is highly inefficient, slow, and labor intensive. And also we have also identified another drawback, that is no existing system provides any analytical insight to the user behavior or any P-card threats. So there comes our proposed solution. So what we are proposing is an integrated digital ecosystem which is centered on a biometric core for secure identification. And it includes mainly three components, that web portal. Talking about the web portal, this web portal is available to the librarians, which they use to control the user and inventory management. So basically, it is a control panel for all the management tasks. Then we have a mobile app which is used by the students or any faculties. And this mobile app provides a e-library where they can browse the books and also and the necessary features are also provided there. Now, the final component is a biometric core where we use a fingerprint-based system for secure and fast identification. The software stack includes, we use Flask for the backend, MySQL for database management, and Flutter for the mobile application. Now, talking about the architecture, what we are proposing is a dual platform ecosystem, which is connected by a centralized cloud. And talking about the mobile application, it provides different browsers, digital circulation. They can also pre-book the books which are not available right now. And the mobile application also provides a personalized dashboard where the students can get notification regarding fines or due dates and everything. And also there is a grievance portal where students can submit any complaints or anything, and also a smart recommendation system which is based on their browsing history. Now, in case of web application, the librarians has inventory and user control, and there's a grievance resolution system. And also the librarians can generate reports, and the manual tasks like fine and due date calculation all are automatic in web application. Now talking about the third component, that is a biometric and AI integration layer. So this is basically how the biometrics works. First of all, we will capture the fingerprint during and scan, we will acquire the fingerprint on access, and this fingerprint is then matched against the repository, and if the matching is successful, then it is authorized, we will grant the issuance, or it is denied. And also we use an AI algorithm to analyze the browsing history and also the departmental data to suggest relevant reading materials. Now, even though it is a work in progress, we have also referred, since we have referred to different papers, we were able to find some of the results which is guaranteed. That is, our system will replace the manual ID cards, and we use cloud database instead of physical registers. And also in traditional system, the recommendation is not available, but we are providing AI recommendations. And also the access time for traditional system is always 100 seconds. Demonstrate a consistent performance. It also ensures the identity verification remains secure without the use of physical cards. So by this, we come to an end. So let me conclude by saying that the BioLit system provides a theoretically grounded, practical, and modern solution. We actually replace the physical registers or ID cards, and it makes the whole system much more faster, more accurate, and highly secure. And we also integrate web application and a mobile application, which will allow the users to manage the resource efficiently. And in the future scope, what we are aiming is to improve our predictive models and also to use IoT sensors for real-time occupancy monitoring. So these are the references. These are some of the papers which we have referred. By this, we come.
Krishnapriya.
Yes, ma'am.
Okay, congratulations, Krishnapriya, for presenting a paper in this conference.
Thank you.
Okay, how that one-to-one matching is done? Is it a linear search or have you used any AI techniques?
Actually, it's still a work in progress, and we are only going to work more on that. So right now, we are actually planning to do a normal search, where this, first of all, we will acquire the fingerprint and we will store it in the form of templates. We will hash and store it in the form of templates rather than image, so that security is enhanced. And later, during the issuance, when the student gives a fingerprint, all the stored templates.
Okay, so what you have done for this personalized dashboard?
In personalized dashboard, the students can view their history regarding which all books they have been issued, what are the available ones, and is there any notification and everything. And also they will get notification regarding their issue dates and also if there's any fines and everything.
So is there any recommendation systems for that?
We are also planning to implement a recommendation system, which is the most basic one, by comparing their department data or their semester data and also their browsing history. So we'll compare in which semester they are, and we will look it with the students of that same semester, and then we'll compare the books which.
Okay, thank you.
Thank you.
Now we are moving to the next presentation. Mr. Binny Thomas.
Hello,
Mr.
can you hear me?
Yes, Binny, I can hear you.
So now I'll be presenting.
Please share your slide. Yes, the slides are visible. You can start the presentation.
Okay. So good morning, everyone, respected faculty and everyone present here. Today, I, Binny Thomas and Hisana Saji will be presenting our paper called Behavior Aware Threat Identification in Cloud Networks using feature-aligned flow logs and hybrid learning. So our intelligent ideas that is made specifically for cloud environments that mainly focuses on insider threat detection, and we use VPC flow log for this. And our team members include Binny Thomas, Hisana, Bhavya, and Shiva HS. Now I'll give hand over to Hisana Saji for presenting the next slide.
Cloud computing environments host highly sensitive data and critical services shared across multiple users and organizations. One of the most serious challenges in cloud security is insider threats. Unlike external attackers, insiders already have an authorized access to the system, making the malicious activities appear similar to normal behavior. Traditional security systems is relying on the static rules and signature-based detection. So often of the user and detect the subtle privilege misuse and also identify the insider attacks. So to overcome these limitations, we developed CloudGuard, a behavior-aware cloud-native intrusion detection system. While reviewing existing IDS system, we identified several research gaps. First is that most IDS models are data-centric and not aligned with real AWS deployment environments. Second is that many systems rely on high-dimensional features sets that are unsuitable for real-time cloud systems. Third is that most approaches use only supervised learning, making them ineffective against the insider threats. So finally, very few systems provide a cloud-native real-time monitoring pipeline. So these gaps motivated our design for our web app. Using flow-level metadata, and we are detecting insider and trusted attackers' activities, and to align traditional NIDS datasets with AWS VPC flow log features, and to develop an ensemble ML model and provide real-time monitoring through an interactive dashboard we have built. Now we would like to hand over to Binny, who will explain our technical methodology and system design in detail.
Okay, so this is our methodology. First, what we have did was we have taken the dataset, specifically CI/CDS 2018 and Web IDS 2023 dataset. Then we performed the basic pre-processing operations such as cleaning the data and merging the dataset. Second thing that we did was we aligned the dataset with the AWS VPC flow logs. That is, initially our dataset had around 79 attributes, but only has 10 features. So we have taken the features that are common in both in the dataset as well as for the AWS VPC flow logs. Then we check the distribution of the attack is to normal ratio. Then what we have observed was the normal data was majority and the attack data was minority, like 90% is to 10%. So what we did was we did class balancing technique. That is by taking the 10% of the attack data and kept it as the 40%. And from the remaining 90% of the normal data, we have sampled out 60% of the data, thus maintaining a 60-40 balance ratio. Then we have split the data into training, validation, and for testing purposes. So initially, when we created the new dataset, we didn't directly go to the final model development. Initially, we tested it on small machine learning models such as tree-based classifier, hyperplane-based classifiers, and neural network-based classifiers based on our models. Then we evaluated the model and its performance. It performed pretty good. Then based on our features of our data, such as our data set is categorical primarily. And so we have used a supervised learning technique called SCATboost. which uses gradient boosting. Then we used USAD technique, which is unsupervised anomaly detector, which is an unsupervised method. And third is the TabNet classifier, which is a transformer-based architecture. Then finally, in the last layer for making the final model, we did an ensemble learning, which is called hybrid learning. Then after that, we have gotten the final trained cloud IDS model. So yeah, we have mapped CI/CDS and WebIDS dataset with AWS VPC Flowlog for practical deployment purposes. And second thing, what we did was we have drastically reduced the number of features from 79 to 10, and yet getting good accuracy. And the data TabNet and USAD, we have primarily trained USAD for detecting zero-day attacks. That is, we have only trained USAD with normal attack samples only. We didn't give it the attack sample so that the USAD can build, can know what normal traffic looks like and can deviate and can detect slight deviation if an attack kind of traffic occurs. Then in the real-time inference pipeline, what it does is we have used AWS EC2 instances for creating the virtual machine, and we have used VPC subnet. That is, we created VPC subnet within that virtual machine itself, and using CloudWatch, we have extracted VPC flow log, and after extracting the flow log, we feature engineered and feature mapping. Then after that, it is passed through an ensemble model. So the ensemble model's prediction and the log is updated in the data. Is that we have and the results will be updated in the dashboard screen itself. So what are the design trade-offs and engineering decisions that we have taken? So first thing that I've already said is we have reduced the features from 79 to 10. Now you might be all thinking, like, will it cost us anything? So we have did this for mainly AWS friendly deployment thing, and for real-time feasibility over maximum accuracy for getting low latency inference, we have used CloudWatch. We have used CloudWatch, and even for CloudWatch for that, and for hybrid detection and for cloud threat visibility, we have structured detection for non-threat and anomaly detection for insider and zero-day activity. And for the fourth thing, for the imbalanced data set, we have balanced the data set in a 60-40 ratio. And for lightweight deployment architecture, we have specifically used CloudWatch ingestion that help directly Python script itself. So for the observation part, what we have seen was the ensemble model gave us the maximum accuracy, and we have successfully identified abnormal internal traffic using flow level analysis. And the supervised model actually improved the precision because it almost has a higher incision, and USAD had a little bit of sensibility. So ensemble balance between that. And for the feature engineering part, we have reduced the features from 79 to 10, and we have feature engineered some additional features over there. And finally, low inference delay with continuous CloudWatch ingestion and dashboard integration. So that is our observation slide. And next screen shows our output screen, which will be explained by Hisana.
Thank you, Benny. So this slide cloud the dashboard. So our dashboard has 4 KPI cards, which is showing the total logs that we have ingested and also the attacks detected in that 56 logs and the attack percentage of the traffic. So here in this log, there is 26.79% of the traffic which is attacked, and the rest is normal. So the most common attack type is the DOS attack, and we are also showing 2 charts, which is the attack timeline charts and the top malicious source IPs from which the attack is coming from. So in our attack timeline, we also have a threshold, which is classifying the attack as high severity, medium severity, and low severity, so that this helps the administrator to check on the attacks that has come in a nice manner. To have a chatbot, NLP chatbot, so that the user, the administrator can query what kind of attack is coming without manually checking the CSV data So the administrator can ask what is the total logs that has come. So our chatbot would give the answer fetching the details from the database. And our chatbot is built for technical and non-technical users. So if the non-technical user is asking what a DDoS attack is, our chatbot is giving an answer according to that too. And finally, our CSV export button is also giving the database in the CSV manner, so that this is very much useful for business intelligence. And we have also used our fast API backend, and we have detected accurately the malicious traffic events. And we have also implemented severity classification, so that the administrator can prioritize the attacks and identify it and work on defending it. And we also have top malicious source IPs and have a interactive real-time dashboard. And we also have a hybrid NLP chatbot, and we have correctly processed the simulated attacks. So to conclude, CloudGuard demonstrates a behavioral-driven we have now, and is effectively detecting the subtle insider attacks that the traditional mechanism is often missing. So CloudGuard complements the existing cloud security mechanism and is a step towards moving to adaptive cloud native security. Thank you for your time. We would be happy to take any questions.
Lily, can you hear me?
Yes, ma'am.
Please switch on your camera. Okay, can you take the first slide?
This one?
First
Hello?
Okay.
Okay. Wherever you are going for a presentation, you have to mention your affiliation, from which college you are coming, your department, all these things should be there in the slide. Okay.
Okay, ma'am.
Okay, ma'am, this was our last reviews paper, so we have used that presentation for that. Sorry for that, actually.
Okay. Anyway, you are presenting outside from outside your college now. So
Yeah.
you have to mention that.
Okay, ma'am.
Okay, ma'am.
So can you take that methodology slide?
Okay.
So, yes. So what is that train validation test split? Then 3 type of classifiers.
Yeah, the thing that we did, we first in that is TAP, USAID, and CatPost. That is like a heavy machine learning models that use many resources actually. So first we have tested the diversity of data on multiple kinds of classes. For that we have validated on random forest, one class SVM, and deep neural network.
So which model you took for deep neural network?
Sorry, ma'am.
Which model you took for deep neural network?
Single ANN architecture itself.
Then why you called it as deep neural network?
We use many layers.
Okay. So what are the features you took for this training?
Okay, the training features mainly conclude the what kind of protocol, that is whether it is TCP pack. Then backward rate, flow rate, all these kinds of things. These are called as metadata.
Okay, thank you.
Thank you, ma'am.
Now we are moving to the last presentation of the session. Miss Alena Margaret Johnny.
So am I audible?
Yes, you are audible. Please share your slides.
Is that visible?
Yes, the slides are visible. You can start the presentation.
Thank you, sir. A wo- I'm here to present on our paper, StrideX Enhancing Marathon Coordination Through Technology. This work is developed by myself and my co-authors, Alina, Akhila, Abhi Krishna, and Ms. Ranjisha. So, StrideX is an all-in-one marathon management solution. We use mobile networking, GPS, and geofence to track participants in real time. This system is built to improve situational awareness, which just means giving organizers a clear live map of where everyone is, making it easier to manage checkpoints and any emergencies that pop up. Why do we need this? Currently, many marathons still rely on method leads to slow response time and lack of real-time data. As more people participate in these events, the expectations for safety and engagement are growing. We need a system that can keep up to thousands of runners at once. Our solution, StrideX brings everything into one place. Self-training mode, registration, tracking, volunteer coordination, and even sponsorship. We build the mobile app using Flutter, so it works on Android, and everything is backed up using the Firebase. We looked at the existing systems like RFID timing, which is precise but doesn't track a runner's location between points. We also located at how smartphones can collect distance and pace. Fencing. This allows us to verify checkpoints automatically without needing a person standing there to manually check the runners in. As for the system architecture, it is a modular architecture integrating the mobile app and the cloud infrastructure, which is the Firebase as the database or the backend. And then in between the logic or server layer is the user interfaces, which our app contains, which consists of user module, marathon and bidding logic, geofencing and GPS tracking at the moment of marathon is being started, then web store and a self mode. Then the tools we implemented are, as I mentioned back, Flutter Flutter is used for the cross-platform mobile compatibility. Then Firebase is the backend in order to visualize. The admin dashboard give organizers immediate insight into how the race is processing. For participants, the app handles everything from registration, including medical history and emergency contacts, to tracking their training metrics like pace, distance, and calories burnt. All this data is synced automatically to the Firestore. As we all know, we need an emergency factor. We all do concern for emergency. So safety is a major feature. If a runner is in trouble, they can use the emergency SOS feature, and this sends their exact GPS location to the administrator immediately for a fast medical response. In our test, we found our timing accuracy had an error margin of less than, proving that while we currently rely on GPS, geofence, and internet signals, our future plan is to integrate with smartwatches and use AI to predict runner performance. In conclusion, StrideX demonstrates how mobile and cloud technologies can transform sports management by replacing manual methods with an integrated platform and foster a more engaged community. These are the references I used. And thank you.
Can you hear me?
Yes, ma'am.
Can you switch on your camera? Okay. So how the backend processing is done?
Ma'am, the backend is used using a Firebase technology. So Firebase is actually used for authentication and other purposes.
What about the GPS data you have collected? How you have done?
As I mentioned in the above presentation, we would integrate it using the Google Maps API.
Okay, thank you.
Thank you.
Joy and Mr. Mahesh for their valuable guidance in successfully completing this session. We deeply appreciate your time, professional expertise, and thoughtful moderation, which ensured the smooth flow of presentation and meaningful technical discussions. Your contribution has significantly enhanced the quality and success of this conference. We are honored by your presence.
So next, we'll be having a short valedictory function, and of course, the participants and faculty or students can share their feedback, and then we will break for lunch and wind up. Okay. So if anybody is sitting in seminar 1, so I think we can start the valedictory function. Okay. So good afternoon to all. So we have come to the conclusion of International Conference on Artificial Intelligence and Engineering Innovations, ICAEA 2026 schedule. Actually, a very informative 2 days, and from all over the world we got papers, and out of that, because of quality issues, some papers were rejected after a peer review, and a stringent peer review process was conducted for each paper by a panel of reviewers from India and also from outside. So at last we accepted around 47 papers, and we can say proudly that all the 47 papers were presented during this last 2 days. So, and also there were 3 keynote speakers. The first one being Dr. Rafiq Tahakoya from UAE. Second keynote address was on same Saturday, yesterday afternoon, by Mr. Shivahiri Nandakumar from Germany. And today we have one another keynote on Navy of TKM College of Engineering. And he has also kindly chaired one session, seminar 1, the venue 1. And so on, we can say a large number of papers are presented and information is shared globally. So thank you everybody for this organizing this function, and especially on behalf of organizing committee of SEET College of Engineering Cherthala, I would like to thank our honorable director, Dr. V. Arun Kumar, Principal Dr. Jaya VL, the respected Dean, Dr. Prita Teresa Joy, Computer Science HOD, and Ms. Elisha Laiju, HOD Tripoli, for their support in organizing, or for their involvement in organizing this 2-day international conference. So a lot of people, few names, of course, everybody is there. So this includes the members of a technical committee, program committee, hospitality committee, documentation certification committee, and members of all other committee. And a special mention to Professor Anida for efficiently organizing all these sessions and chairing or heading the program committee so that we experienced minimal delay or not at all any delay in conducting all these sessions. You can see we are on time and much before time. So that was a lot of hard work from Ms. Anida. So thank you. And special mention to Mr. Ajit Kumar of the technical committee for arranging everything. And we are, as you know, we are organizing this thing in a hybrid mode. Participants were from our college, students from our college, but external participants were also there. So for arranging all these things with the minimum obstruction and or with the minimum delay by interfacing all these technical things, it's a huge job. So special mention to Mr. Ajit Kumar. Thank you. And then Professor Janu, I think in her absence here, you can say. So Professor Janu worked very hard for this. And then the program certificate and documentation committee members, including Dr. Vishnu Priya, Sita Mol, Jinsi, Rena Grayson, Nikhil Dev, Munir. Then seminar one hall was efficiently convened by Ms. Anupama and her team. Then Ms. Renjusha and from Model Engineering College. She has been here for the past 2 days. So he was behind all the technical aspects, or you can say he has chaired 2 sessions. Along with that, he was very helpful in organizing all this. And thank you, sir, for all your support. And then special mention to Mr. Ajay Nath. I think he's not here. So he's actually behind the organizing of this conference from the very start, from November onwards. So on behalf of College of Engineering Cherpalla, I would like to thank Mr. Ajay Nath for all his support. And our external participant who presented one paper offline, Darshana, I thank her also. She has also sessioned a chair. And then special thanks to Jamshid, Rashida, and then Meera Tambi. So thank you, Meera. And then special thanks to everybody actually, including Anisha Muhammad for chairing that, for heading that program and documentation committee, certificate committee, and then the Miss Josmin of office, Winston and Joanne, and very nicely organized, Joanne and Winston. Then Mitti, George, Sajish, even though some are not here, special thanks to all of them. Mr. Matthews. Mr. Matthews is very, very efficient. Then Miss Liji, Fatima. Then the student team. Special appreciation to the student team led by Hari Govind, Ridil, Hari Krishna, Lasin Becker. So you have very neatly covered everything, streamed everything. So congratulations. Everybody worked so hard for this and making this 2-day conference a success. So finally, a big thank you to all. Thanks again. Next, I would like to invite Dr. Priya Teresa Joy, the co-general chair of this conference, to say some words.
Good morning, all. So when we started this conference, our aim was to provide a platform for the students to present a paper in a conference. With that aim, we kept the registration fee very minimal, so that this registration fee cannot be a barrier for the students for presenting a paper in a we got a very good response, positive response from all the students. And I hope that all the students who presented their papers in this conference, got an idea or got a confidence in presenting papers in a conference, how the papers are written, all these ideas they got, I think they are all benefited from this conference. Also for the college, this conference gives a positive environment and reputation from the college point of view. So we can continue this in the next year with all your support. Thank you all. Thank you all for your cooperation and support. Thank you.
Next, I invite the participants to share some feedback of theirs. You're welcome.
Respected dignitaries, organizing committee members, and my dear colleagues and all dear participants. I would like to sincerely appreciate the tremendous are clearly reflected in the smooth execution of this conference, two-day conference. The sessions were highly informative and covered diverse and emerging research areas, both BTech and MTech projects level. Then the technical presentations were well structured. The time management and smooth coordination throughout the event truly reflect the dedication and hard work of this organizing team. It is truly commendable that this is the first conference organized by the team. The professionalism and the quality maintained throughout the event are remarkable. For a first edition, this is very much remarkable. Then I am confident that this conference will grow stronger in coming years and attract even more researchers and participants. I look forward to it. I'm very glad this is my first conference and my first presentation in the conference level, and I am very grateful for the opportunity, and thank you.
Any more feedbacks? So JMS, are you there?
Yes.
Yeah, please have some
I'm listening.
concluding remarks.
Okay. It was a very wonderful 2 days organizing the international conference in a very good manner. I sincerely would like to extend my thanks to all the public, and special mention to the organizing committee, especially Dr. Binesh T, the general chair, who did all the preliminary works, and a special mention to Sri Ajaynath, the research scholar of Dr. Binesh T. He did all the preliminary works silently and effortlessly, and actually 1.5 weeks back, basically the work is shared with all of us, and definitely in that short period all the we formed a committee, and I mean different committees, and the committees work well. I'm very happy to see that all the and that's all, and very happy to hear that all the 47 participants presented their papers in the conference, and definitely as promised, good works will be published in the IHRD journal, and hoping for the best. Thank you.
Thank you, ma'am. Anybody wants to share their thoughts? Can come here.
I have attended many of the sessions in this conference, and it was very informative and beneficial. I got benefited with making the conference a success. I thank all the program organizing committee members for making this session fruitful to us.
So thank you, Jayasree ma'am. And special thanks also to the hospitality committee head, Sindhu ma'am, for her delicious treats. So if there is nothing else, I think we can wind up. So thank you all once again. Thank you. Photo